Hi everyone, this is going to be a quick mini lecture, kind of talking about two main points of confusion in asymptotics. So the first point of confusion for a lot of students is what is best case runtime? So suppose that we're looking at this function f defined over here, and I ask you guys, what's the best case runtime of f? Here is, I want to emphasize, an incorrect line of reasoning that a lot of students use, and it goes as follows. So students, what they say, which isn't correct, is that suppose that n is passed in as 1,000, okay? In this case, what we'll notice is that this function will take constant time because we will exit immediately, right? So we can kind of see here that this doesn't make any sense because we only really care about asymptotics when n is really, really big. So we can't hard code the best case behavior to be the specific case when n is equal to 1,000 or less. Okay. More generally, the reason this line of logic doesn't work is because I'm just reiterating this because it's very important. Asymptotic analysis is only defined when n is really, really big. So repeating this once more because it's very important, is that we only care about asymptotic analysis when n is really, really big, right? And this should make sense because asymptotic analysis is trying to figure out the long-term behavior of a function. So how this translates into the best case runtime is we can't look at the function f and say when n is equal to 1,000, it's constant time, because that's violating this idea of asymptotic analysis as only considering cases when n is really, really big, right? So with that in mind, the best case runtime of the function f, if you guys are curious, is actually the exact same as the worst case because the function f always takes the same amount of time. Okay, so we can kind of see that f will take linear time. So the best and worst case of f is going to be linear. But anyways, so moving on to the next point of confusion is why can we use a theta bound to describe the best and worst case behavior of a function? So here's like an example from the exam prep worksheet where it says determine the best and worst case runtime in theta notation as a function of n. So as you guys, if I don't know if you guys actually did this problem in the worksheet, but you guys may not even noticed that there's a theta bound there, right? So why can we use a theta bound to describe the best and worst case runtime, right? Like why aren't we using like an omega bound or why aren't we using a big O bound, okay? So this is definitely really confusing for a lot of students, and it was confusing for me when I first learned this in the class. So no worries if you guys like kind of confused here. So the reason we can use a theta bound when we describe the best case and worst case runtime of a function is because the best case runtime of a function, as well as the worst case, always takes the same amount of time, right? Intuitively, when we think about a theta bound, what this is communicating to us is the idea that a function always takes this amount of time to run, okay? Looking at this first function f, we can use a theta bound to describe the runtime of f because it always takes the same amount of time, right? In the same light, let's imagine the worst case behavior or best case behavior of the function prime factors, okay? This is a quick spoiler, but the best case behavior of prime factors is always going to be log n, okay? So when we think about the best case runtime, it's always log n. Because of that, we can use a theta bound to describe it, okay? When we think about the worst case behavior of prime factors, which is the square root of n, we notice that the worst case behavior of prime factors always takes the same amount of time. And because of that, we can use a theta bound, okay? So when you guys see problems on exams, you guys see problems in future discussion worksheets, notice that if we have a theta bound for best and worst case, it should make sense to you guys because the best and worst case runtime of a function always takes the same amount of time, right? So that is all for this video. Hopefully this helped. And yeah, good luck on the worksheet.